Welcome to Technically You, the podcast where we break down complex cybersecurity concepts into digestible insights.
And folks, today we're tackling something that sounds boring, but is actually fascinating. Network access control.
Did you just call access control fascinating? Every adult listener gets to take a shot.
Hey, it is fascinating. It's literally the bouncer at the club of your network. Who gets in? Who gets kicked out? Who gets the VIP treatment?
Okay, I'll give you that. The bouncer analogy is actually pretty good.
Thank you. I've been working on that one.
So, whether you're a security professional, IT admin, or just someone who's curious about how organizations control who gets access to what, this episode is for you. We're going to explore everything from the basics of NAC to the sophisticated access control models that make it all work.
And we promise to keep it interesting. Just make sure I don't go too deep into the technical weeds.
That's literally my job on this show. All right, you set up the bouncer analogy. Run with it. What exactly is network access control?
So, imagine you're trying to get into this exclusive nightclub, right? The bouncer doesn't just check your ID. They're looking at your shoes, checking if you're on the guest list, and checking what you're carrying.
I feel like there's a personal story here.
Whatever, we're not talking about that. But NAC does the same thing for your corporate network. It authenticates devices and users. That's the ID check. It assesses the security posture. Are you running antivirus? Are your patches up to date? That's the dress code.
And then it authorizes access based on who you are, what device you're using, and whether you're compliant with security policies.
Exactly. But here's where it gets cooler than an actual bouncer. NAC keeps monitoring you even after you get in. If your device suddenly becomes non-compliant, or if you start acting suspiciously, it can quarantine you or boot you out entirely.
So it's a bouncer with trust issues.
The best kind of bouncer. In cybersecurity, trust issues are a feature, not a bug.
Fair point. So NAC isn't just about building walls. It's about intelligent gatekeeping that adapts to context and risk.
And to make all these decisions, NAC systems rely on various access control models. These are basically the rule books that determine who gets access to what.
Which brings us to the meat of today's episode. We're going to walk through 6 major access control models. I know you love all of them equally, but which one should we start with?
Well, like any good story, we should start at the beginning, with the oldest and simplest, discretionary access control, or DAC.
DAC. So what makes it discretionary?
It means the owner of a resource gets to decide who can access it. It's the my house, my rules approach to security.
Oh, so like when I share a Google Doc and decide who can edit versus who can only view?
Perfect example. You created the document, so you control who gets what level of access. That's pure DAC.
Okay. So what's the problem? That seems pretty reasonable.
The problem is that people are terrible at making security decisions.
Wow. Tell us how you really feel.
I'm serious. Users will share sensitive documents with everyone at the company because it's easier than selecting individual people. They'll give edit access when read only would be fine. And here's the scary part. If malware gets on your computer, it has all the same access you do.
Oh, that's not great.
That's why we call them Trojan horses. They're running with your permissions, so they can access everything you can access. DAC has no way to stop that.
So, when would you actually use DAC?
It's fine for non-sensitive stuff. Personal files, collaborative documents where flexibility matters more than security, but you definitely want other controls layered on top.
Got it. So, we need something stricter. Which brings us to...
The complete opposite, mandatory access control, or MAC.
Let me guess. Nobody gets discretion with this one?
Bingo! MAC is what happens when security people get to make all the rules and users get to follow them. No exceptions.
You're really selling this.
Okay, hear me out. In MAC, a central authority assigns security labels to everything. Every user, every file, every resource gets a classification.
Like military clearance levels?
Exactly. Top secret, secret, confidential, unclassified. You can only access stuff at or below your clearance level, and you can't just decide to share top secret documents with someone who only has secret clearance, even if you really, really trust them.
Even if it's your boss?
Even if it's your boss. That's what makes it mandatory. The policy is enforced no matter what.
I can see how that would prevent data leaks, but it sounds like it would be incredibly frustrating to work with.
And you've just identified the fundamental trade-off in security. MAC is amazing for preventing unauthorized disclosure, but it's rigid and complex. It can actually prevent people from doing legitimate work if the policies are too strict.
So, where do you actually see Mac in the real world?
Government systems, military networks, high security facilities, and actually your Android phone probably has SELINUX running, which is a MAC implementation.
Wait, my phone?
What you use in Android? Well, yeah, it's running in the background, making sure apps can't access things they shouldn't. You never see it, but it's there.
Interesting. The more you know. Okay, so we've got the Wild West of DAC and the Iron Fist of MAC. Is there something in between?
There absolutely is. Let me introduce you to what's probably the most popular model in enterprise environments, role-based access control, or RBAC.
Okay, RBAC. This sounds like it's based on job roles.
You got it. Instead of assigning permissions to individual users, you assign them to roles. Then you just assign users to the appropriate role.
So, like, manager gets one set of permissions, developer gets another set, intern gets barely anything.
Hey, interns get access to the coffee machine and the bug tracker. That's all they need.
You're terrible. Are you trying to get us canceled? But I see the appeal. If you have thousands of employees, managing individual permissions would be a nightmare.
Exactly. Imagine a company with 5,000 people. Managing individual permissions? Absolute chaos. But with RBAC, you might only have 50 roles. New accountant joins? Boom, assign them the accountant role, and they automatically get access to all the accounting systems.
What happens when someone changes jobs?
You just change their role assignment. Sarah goes from senior security analyst to director of security. Update the role, and all her permissions automatically adjust.
That's actually pretty elegant. What's the catch?
The catch is what we call role explosion.
That sounds dramatic.
It is. Organizations start with 20 nice clean roles. Then someone needs an exception. Then another person needs a slightly different combination. Before you know it, you have 500 hyper-specific roles like junior accountant, who also needs occasional database access only on Tuesdays.
That's oddly specific.
I may have seen that exact role name in a client environment.
No way.
I'm not joking. RBAC can get messy when people try to make it handle every edge case. It's also not great at handling context, like maybe a manager should have different access when they're at home versus in the office.
Can RBAC do that?
Not easily. Which brings us to what I think is the future, attribute-based access control, or ABAC.
Ooh, you have a favorite. I can hear it in your voice.
Okay, I'll admit it. A BAC is my favorite.
Of course it is. You love complicated things?
It's not complicated, it's sophisticated. ABAC makes access decisions based on attributes, characteristics of the user, the resource, the environment, everything.
Give me an example.
Sure. Instead of asking, is this person a manager? Which is RBAC, ABAC asks, is this person a manager in the finance department with an active contract accessing during business hours, from a corporate IP address, on a compliant device trying to read a financial document classified as confidential?
That's a lot of questions.
But they're all relevant. Maybe we want managers to access financial data, but only from corporate networks during business hours. A BAC can enforce that. RBAC would struggle.
So it's like context-aware security?
That is a perfect description. It's security that adapts to the situation. You accessing sensitive data from your office laptop at 2 p.m.? Probably fine. Same access request from a coffee shop at 2 a.m. on a personal device. That's getting flagged.
Okay, I'll admit that's pretty cool, but it sounds complex to set up.
It absolutely is. You need to identify all the relevant attributes, define policies for how they interact, and manage all the sources of that attribute data. It's not trivial.
So, when would you use it versus RBAC?
Start with RBAC as your foundation. It's proven and scalable. Then layer ABAC on top for your most sensitive resources or when you need those context-aware decisions. Best of both worlds.
That's actually sensible advice. I'm impressed.
I have my moments.
Don't let it go to your head. We've got more models to cover. All right, what's next? And please tell me it's not more complicated than ABAC.
Well, funny you should ask. Let's talk about lattice-based access control, or LBAC.
Oh no, that sounds mathematical.
It is. LBAC uses lattice theory to define hierarchical relationships between security levels.
You're losing me already.
Okay. Simpler explanation. Imagine you have information that's classified in multiple dimensions.
Multiple dimensions? Are we doing sci-fi now?
Stay with me. Let's say you're in the military. Information might be classified by secrecy level, top secret, secret, confidential. But it might also be classified by category, NATO, nuclear, intelligence. To access a document, you need the right clearance in all dimensions.
Oh, so you can't just have top secret clearance. You need top secret and nuclear clearance to access that specific document?
Exactly. That's the lattice structure. And LBAC has strict rules about information flow. You can't read information above your level. That's the no read up rule. And you can't write information to a lower level. That's no write down, which prevents accidental declassification.
That second rule seems weird. Why can't someone with top secret clearance write to a secret file?
Because then you might accidentally put top secret information into a secret file. And suddenly people with only secret clearance can read top secret intel.
Oh, that's clever.
LBAC is all about preventing information leakage with mathematical guarantees.
But I'm guessing this isn't something most companies need?
Correct. LBAC is really for military, intelligence, and maybe highly regulated industries. It's overkill for most organizations.
Unlike MAC, which is appropriate for everyone's Android phone, apparently.
Different use cases for different models.
So, we've got one more to cover, right? RSBAC?
Last but not least, rule set-based access control, and this one's a bit different from the others.
Different how?
RSBAC isn't really a single access control model. It's more like a framework that lets you implement multiple models or even create your own custom ones.
So, it's the choose-your-own adventure of access control?
Yes, actually, that's a great way to put it. RSBAC is a Linux kernel security framework. You can enable Mac modules, RBAC modules, or write completely custom security policies.
That sounds incredibly powerful.
It is. You can mix and match models. Use MAC for your classified data, RBAC for general application access, and custom rules for anything unique to your environment.
But I'm sensing a but coming.
But it's complex, like really complex. You need deep Linux kernel knowledge to implement it properly. The learning curve is steep, and if you misconfigure it, you can lock yourself out of your own system.
Ouch.
Yeah, I've seen people brick their systems during RSBAC configuration. It's not for the faint of heart.
So, who actually uses this?
Critical infrastructure, high security financial systems, government installations, places where standard models aren't sufficient and you need maximum flexibility. But it's definitely a specialist tool.
And it's Linux only?
Yep, Linux specific. So if you're running Windows or Mac OS environments, RSBAC isn't an option.
Got it. So, we've covered 6 different models. How does someone actually choose which one to use?
Great question. And the answer is, you probably use multiple models.
That feels like cheating.
It's not cheating. It's layered security. Most organizations use a combination. Here's how I typically recommend people think about it.
I'm taking notes.
For general enterprise IT, start with RBAC as your foundation. It's proven, it scales well, and it aligns with how organizations actually work. Then layer ABAC on top for sensitive resources or when you need those context-aware decisions we talked about.
What about high security stuff?
For truly sensitive data, classified information, trade secrets, critical infrastructure, implement MAC or LBAC. Use the strict controls where they matter most.
And DAC?
DAC is fine for user-managed resources, personal files, collaborative documents. Just make sure it's within a broader framework of organizational policies.
What about cloud environments? Everything's moving to the cloud now.
Cloud-native applications should absolutely embrace ABAC. Cloud environments benefit hugely from attribute-based policies that can handle dynamic, distributed resources. You can't rely on network location anymore, so you need identity and context instead.
This makes sense. Use each model where it makes the most sense rather than trying to force one model to do everything.
Exactly. Security is all about defense in depth. You might use MAC for your most sensitive data, RBAC for general application access, ABAC for cross-system policies, and DAC for user-level file sharing, all in the same organization.
And if someone's using Linux and needs maximum flexibility,
Then RSBAC is on the table, but they better have a Linux kernel expert on staff.
fair enough. So let's bring this back to where we started. Network access control. How do all these models actually work together in a NAC solution?
Modern NAC solutions are pretty sophisticated. They integrate these access control models to make intelligent decisions in real time.
Give me the practical stuff. If someone's implementing NAC, what should they know?
First, and this is crucial, start with visibility. Before you enforce anything, you need to understand what's actually on your network
That seems obvious, but I bet people skip this step.
all the time. They jump straight to enforcement, and suddenly half the organization can't access critical resources. You need to know what devices are connecting, who's using them, and what their security posture looks like before you start blocking things.
What's next?
Implement zero trust principles. Never trust, always verify. Even devices inside your network should be continuously authenticated and authorized.
Annoying for users?
It should be transparent. Good NAC implementation is invisible to legitimate users. They don't notice constant re-authentication happening in the background.
What else?
Use risk-based policies. This is where combining RBAC and ABAC really shines. Your CFO accessing financial systems from a corporate laptop in the office, full access, no friction, same CFO on a personal tablet from a coffee shop, maybe read-only access with additional authentication.
I like that. It's security that adapts to risk rather than just saying yes or no.
Exactly. And here's another important one. Automate remediation. When a device is non-compliant, don't just block it and walk away.
What should you do instead?
Quarantine it and provide self-service instructions for fixing the problem. Your antivirus is out of date. Click here to update it. Help users get compliant rather than just punishing them for non-compliance.
That's surprisingly user-friendly advice coming from you.
I contain multitudes, but seriously, the most secure policy that nobody can work with is useless. You need to build in exception processes and temporary access mechanisms for legitimate needs.
What about ongoing management?
Monitor and adapt. Access patterns change and threats evolve. NAC policies should be living documents that get refined based on real-world usage.
Not just set it and forget it.
Never set it and forget it. That's how you end up with security policies that made sense 5 years ago, but are completely inappropriate now.
All right, you love predicting the future. Where is all of this heading?
Ooh, I do love this question. So AI and machine learning are already changing access control.
Of course they are. Is there anything AI isn't supposedly revolutionizing?
Fair skepticism, but this actually makes sense. Machine learning systems can learn normal behavior patterns and detect anomalies. They can calculate dynamic risk scores and adjust access in real time.
So, if I normally access files during business hours and suddenly I'm downloading gigabytes of data at 3 a.m.,
The system notices that's abnormal and might require additional authentication or limit what you can do until it verifies you're really you.
that's actually pretty cool. What else?
Identity-centric security is replacing network-centric models. With remote work and cloud adoption, the network perimeter is dissolving. You can't assume people inside the network are trustworthy anymore.
Because inside the network doesn't really exist when everyone's working from home and using cloud applications.
Exactly. So access control has to focus on identity and context rather than network location. Who you are, what you're trying to do, and whether that makes sense, not where you're connecting from.
What about continuous authentication? I feel like I've heard that term thrown around.
That's another big trend. Instead of authenticating once when you log in and then having access until you log out, systems continuously validate your identity.
How? Am I constantly typing passwords?
No, it's invisible. Behavioral biometrics, how you type, how you move your mouse, how you interact with applications, device posture checks, activity monitoring. The system is constantly asking, is this still the legitimate user? Without bothering you.
That feels a bit Big Brother-ish.
There's definitely a privacy conversation to be had there. But from a security perspective, it solves a real problem. Traditional authentication happens once, then assumes trust for hours. That's a vulnerability.
Fair. What about blockchain? Everyone was talking about blockchain for everything a few years ago.
Decentralized identity and blockchain-based access control are being explored, especially for cross-organizational access. But they're still pretty early in adoption. Jury's out on whether they'll actually become mainstream.
So, the future is more intelligent, more dynamic, more focused on identity than location.
And hopefully more user-friendly. The goal is to balance strong security with good user experience. Security that prevents people from doing their jobs will just get bypassed.
Words to live by. Speaking of which, we should probably wrap this up before we lose everyone.
Right. Let's recap what we've covered today.
We started with network access control, your intelligent bouncer for network resources. It authenticates, authorizes, and enforces policies based on various access control models.
We covered 6 models. DAC gives users control but can be risky. MAC provides strict, centralized enforcement for high security needs.
RBAC is the enterprise workhorse, scalable and practical for most organizations. ABSC is the sophisticated option for context-aware, dynamic decisions.
LBAC brings mathematical rigor for multidimensional security needs, mainly in military and intelligence contexts. And RSBAC is the flexible framework for specialized Linux systems.
The key takeaway is that you don't have to choose just one. Most effective security strategies combine these models.
Use RBAC as your foundation, enhance with ABAC where you need flexibility, and implement stricter models like MAC for your most sensitive stuff.
And remember, good access control enables secure, efficient work. It's not just about saying no.
Saying yes to the right people, at the right time, in the right context.
On that surprisingly philosophical note, we're going to wrap up. Thanks for joining us on today's dive into network access control.
If you found this valuable, subscribe to Technically You wherever you get your podcasts. Leave us a review. We read all of them,
Even the mean ones.
especially the mean ones. They're the most entertaining.
And if you have topics you'd like us to cover, leave us a message.
Until next time, stay secure and stay curious.
And maybe update your passwords.
Oh God, Sarah, we're not starting the password debate again.
We'll save it for next episode.